ओके गुड मॉर्निंग। आज कोई आने वाला नहीं है। Just wait for 5 minutes. Acha, check if you have this file cars.csv. Just check. LMS. Either LMS or in your local system directory you would have downloaded. You probably use this in linear regression or some KNN or something, I'm not sure. Where we have to predict the miles per gallon, MPT. That one. Have it? Yes. Okay, okay, good morning, everyone. So we'll continue with the last bit of theory which is remaining. Okay, that is the gradient descent. I won't get into the maths part. Okay, just a quick overview. So yesterday we discussed about deep learning. Why is it called deep?
Continuous learning.
Deep. Why is it called deep?
The multiple layer.
Multiple layers, right? Okay. Okay. So what are the different types of layers?
Node. Function.
Layers. How many layers are there?
Three.
Three layers. Okay. What are they?
Input, black box.
Input, hidden, and output. Okay. What is an input layer?
Variable input.
Sorry?
Consists of nodes.
No, input layer.
Value function. The data.
Input layer is the features. Okay. What is an output layer? The prediction or the Y variable. Okay. What is hidden layer consist of?
Network.
The network that we built. Okay. What is a node?
Information is particular age, experience, salary.
node contains the information that you get from calculating the values that you get from the previous layer. So when the data is converted into a range, what is used?
Standardization.
Yeah.
Activation function is used. Okay, fine. Okay. Now we will see couple of two things. Number one is how to build the network. And before that, we have to see how many features get built at the end of the network. Okay. At the end of the network, when we build everything,
At the prediction.
you can say a during model. Okay, so that is we are taking care of the input, the weights, the biases, the loads and the layers, all these things put together, how many features get built? Okay.
Why is it? Why is it?
Features. Okay. So I'll just give you the count, how to calculate it. So let's assume that we have 12 features. So 1, 2, 3, 4. Okay. So how many features are there? 12 features. This is input layer. Okay, now I have the this is my hidden layer. Okay, now in the hidden layer, I'm going to have my first layer. I'm going to put 1, 2, 3, 4, 5, 6, 7. Okay, so let's assume that I'm putting 7 nodes. So how many features will be here overall? No, very close to the answer. How did you get 84? 12 into 7.
Plus C.
Very good. Plus C. So 85. So 12 into 7 plus 1, which is 85. If I have 1, 2, 3, 4 features here, then
After 7 or the only 4?
activation function क्यों चाहिए? हमको features चाहिए ना? Activation function will be part of this.
Okay.
28.
So this is 4. So कितना होगा? So this is 85. This is 7 times 4 plus 1. So how much?
29.
Are you getting the calculations?
Yes. Previous node converted into feature.
So each calculated value that you're getting is a feature, which is nothing but a tensor. So total features कितने हुए? Understood? So this is how the calculations are done. Most couple of people ask during interviews, how do you calculate the features? So you can say multiplied plus the bias term, which is 1 for every layer. Okay. Okay, now we'll go into the last part, which is known as the gradient descent algorithm. I won't explain the अगर आपको ये मैथमेटिक्स करना है, that is if you want to see the implementation of this, next week we will do. Okay. Today we will just touch upon some terms like learning rate and all, epoch. Okay, and then we'll directly get into the creation of layers to do a linear regression implementation using deep learning. Okay. Now, what is gradient descent? This is an optimization algorithm. And what does this optimize? The weights and bias. Weights and bias terms you can write. Now, yesterday we learned a term called as back propagation. क्या मतलब उसका?
It goes back and forth. More than equal.
First, it will calculate
हाँ,
and one feature inside that layer. Then it will go back to
हाँ,
the input layer, then it will again come back with the different.
correct. So back propagation is a technique of optimizing the weights so that you get a value expected, a predicted value which is very near to the expected value. Okay. Now, in an optimization algorithm, we cannot change the actual data. Okay, X cannot be changed. So the only thing that you can change is the W, which is the weight, and the bias term. B लिखता हूं मैं. Okay. Now I gave you the little bit of the maths part yesterday. How do you calculate the new value for W and new value for B?
Different.
By finding the partial differentiation of the weights with
Error.
respect to errors. Okay, so we calculate the dW upon dE, and we calculate the dB upon dE. Okay, so this represents the rate of change, and the new weight becomes the old weight minus the differential. Okay. Now, for how many times this has to be done? Because first time I do, I take a random number, right? First iteration, it's a random number. From the second iteration onwards, it is going to optimize that random number. And that is where we use this equation.
Unless and until it comes to zero.
Then there is no 0 to 1. 0 to 1 is activation function. ये activation function नहीं है. Now we are talking of the gradient descent, where we have to optimize W and B. Okay. So how do I know that I have to stop at a certain number? So that is known as an epoch. EPOCH. It is called epoch. Abhi model building mein, this is one of the parameters that you have to specify. How many times or how many iterations you want. Very few iterations will not optimize the parameter. Too many iterations will take a long time, but the iteration will not, the algorithm will not converge. That is, it will not obtain the global minimum. There is a term called global minimum. That is, your expected value and the predicted value should converge so that error is 0. Okay, so that will very rarely happen because we have a float number. So 0 equals 0 is very rare. So we want to minimize what is the difference between expected value and the predicted value?
Epoch definition will be how many iterations required to reduce.
To optimize the bits. समझ में आ गया? Okay. Now, there is another term which is called LR, which is learning rate. Now imagine that this is a ground and you are on a hill. Okay, you are trekking. I think I gave this example before. nahi? ठीक है. So this is a hill or a mountain and you are on the hill. Okay, you are here. Let's say this is your current position. And you have to reach this point. Okay. What is the shortest way, quickest way to reach from point A to point B? It's a mountain. Seedha giroge, you will die. Isn't it? You cannot fall like this. Okay. So you first go here, you check whether the next path is good or not good. I'm explaining the concept of gradient descent algorithm. Okay, so you take a step. Okay, this is fine. So now this is your current position. So you look here, you find, okay, this is good. Okay, now you check for the next point. Okay, where do I go? I go here. Okay, then this. You keep doing this. And then finally you arrive at the location. Okay, this is just an idea that how gradient descent works. So this point B is known as the global minimum. So you have to achieve this target. Okay. Now this step that you take. Okay. So this step that you take will determine how fast you reach or how slow you reach. I'll jump from here to here. Okay, I take 2 steps. And then I take 2 steps. Then I take 2 steps. Now there is a possibility that I will go beyond the global minimum. Right? There is a chance. Or if I take steps like this. So what is going to happen if I take steps like this? Time consuming. Okay, baby steps will take a lot of time. Too many steps will overshoot and you will not achieve the global minimum. Okay, but few number of steps. But I want to take the step size in such a way that it is fast also and it will achieve, if not the exact value, but somewhere close to global minimum. So that step size is known as learning rate. Here. So when we are calculating the new weight, we also take into account the learning rate. So we multiply the learning rate into this difference, that is into this parameter. Okay, so learning rate jo hai, it's usually a very, very small number. It will be something like the 0.002, 0.001, very small numbers you start with. Okay. समझ में आ गया? This is the working principle of gradient descent. So now translate this to what we studied yesterday. So we have random weights for W and B. Okay, now this is the first iteration. Right at the top, I have random values. Now the first step that you take, it is going to optimize this value by calculating the rate of change, which is
Differentiation.
the difference. Okay, followed by multiplying this with the learning rate. So now what is going to happen? W, if it is a positive number, will further reduce. And if B is a negative number, it will increase. Okay, so depending upon how many epochs are defined, it is going to arrive at this global minimum. If I give a value of 10 epochs, what is going to happen? It will stop somewhere here. Okay, so you'll have a big difference. If I take too many numbers, let's say 10,000. So it is going to take a lot of time to optimize that value. Okay, so always start with a small number, see the performance, then slowly increase the epoch, change the network, change the activation functions, change the number of layers, nodes, and the learning rates. And that is how you get the best model. Okay, so here, what are the hyperparameter tuning that you can do? Number one, network. Network में क्या क्या आएगा? Layers and nodes. Then learning rate. Number three. Clear है ये? Ankita, any questions? Idea clear है? Okay. So with this knowledge, we can build the ML models using deep learning. Okay, so we have already learned what are the different types of layers. ये क्या layer है? What we are going to build now? That is called layer.
Network.
कहाँ गया भाई? So this is input layer, this is hidden layer, and this is output layer. तो इसको क्या नाम देते हैं? There's a name for this. कल बोला था ना, end of the class we were discussing. That is the name of the overall process. This is called fully connected layer. याद है? This type of an architecture is called fully connected layer. Information कैसे pass होता है? How does the information pass?
Input first, however, it will go to first node, then it will go back. Then all first and go to the second node.
कैसे जाता है? From left to right. It is always sequential. Isn't it? So this is sequential left to right. So just write it here. Sequential left to right. So this is also known as a forward propagation. This is called forward propagation.
In general, backward propagation.
हाँ है ना, मशीन लर्निंग पे है ना. Okay, so these are some technical terms that we use. Okay, so now let's go to the hands-on section. So I have a data set called cars. ये I think आपके पास भी शायद रहेगा ये cars का. To predict the MPG. Just check. So open the Spider app. Spider कौन सा environment का? TensorFlow environment. Okay, so click on the start. Now see here, Spider for Anaconda, Spider for TensorFlow. Okay, so we have to use Spider for TensorFlow. वो है ना ऑलरेडी आपके पास लीनियर रिग्रेशन का। Wait, let me show you which data set we are going to work with. ये वाला नहीं है ये वाला। चेक करो, if it is not there, I'll share this. कौन सा डेटा सेट है बोलो, फॉर लीनियर रिग्रेशन क्या था? You have this,
I have
the same data set ना?
Yes.
तो how come तुम्हारे पास कैसे नहीं है? पार्थ है तुम्हारे नहीं, यश ने भेजा है, जस्ट चेक। Done? Okay. Ankita, do you have this file with you?
Yes, sir.
Okay. Okay, so let's start. So here we are going to do a linear regression using deep learning, and we have to predict the miles per gallon. ये data set अब सबको पता है ना क्या है? So we have a cars data set with numeric features. We have to predict MPG. Okay, so here we have a feature called name, which we have to remove because it's a character. Okay, other things are numeric. Now, what is the first thing that you have to do on a data set? clean up the data. Okay. So first is we'll remove name, check null, all the usual EDA stuff, whatever you have learned. Okay. First, clean the data. Second, normalize the data. Okay, so this has to be converted into a normalized form. Okay, what are the normalized functions that you have used?
Standard scalar, min-max scalar.
Standard scalar, min-max scalar. Okay, we can use either of these two. Okay,
There was third one.
wait, standard scalar is it's good. Min-max scalar, we'll use min-max scalar because that is between 0 and 1. We can also use the sigmoid function that will also convert between 0 and 1. Okay. But sigmoid is generally avoided. Sometimes it gives you very small values. But min-max is something which is used globally. Okay, so let's get started. So we'll start with import libraries. By दिख रहा है क्या? Is it visible? Train test split is for splitting the data into training and testing. Pre-processing will include the min-max scalar or standard scalar. We can choose any one. Then So these are the basic libraries.
Second import उसका SQL learn model. Do we need to install anything?
समझा नहीं क्या हुआ?
मुझे कह रहे हैं remote module name SQL.
स्पेलिंग चेक करो, अपर केस लोअर केस तो नहीं है. No module name SQL. Go to Anaconda navigator. Navigator.
इसमें काम जुपिटर में काम
हाँ, navigator application. Anaconda navigator. Open that. Go to the environment and select TensorFlow. Not installed this scikit search tool. SCIKIT. Request. So I think it is not installed. Click on scikit learn. You can install. Last time here, yes, it will install.
TensorFlow किया था. सारी चीज़
Not installed. Second option. यहाँ पे SCIKIT type करो. Ankita, are you also getting that error? Scikit error? Hello? Hello, Ankita?
No, sir.
Are you getting this error? In any module not found error?
No, sir.
Okay, fine. हो गया इंस्टॉलेशन, चल रहा है. SCIKIT scikit.
Will require my lot of.
What do you mean?
केरा से क्या सीबोन के लगेगा वापस सीबोन लगेगा
Sorry, Keras कह रहा हूँ, Seaborn, Seaborn. Seaborn.
मुझे भी रोजना है पर मुझे ज्यादा नहीं पता रिजन को प्रोटीन खाइए ना कैसे अरे दिना ठीक है तो itu pun udah kaya deh. Nah, ini baru tuh. Speed test के लिए आता है डाउट कर नहीं अरे जब तुम देख लीजिए ना यानी स्पीड टेस्ट के लिए डायरेक्ट क्या होता है 6.5 मिनट माना गया है हम काम नहीं से है तो मैं प्रोसेस इसका किधर से है ये नहीं किया लेगा ये नहीं आता ये नहीं आता दे रहा है
इंस्टॉलेशन होने के बाद ये दोनों डाउनलोड इंपोर्ट करो सीक्वेंशियल लेयर्स मॉडल एंड डेंस लेयर्स What installation?
दो एक साथ कर सकते हैं
dense layer
नेटवर्क में
यहीं पे हम डिफाइन करेंगे व्हाट इज माय इनपुट नंबर ऑफ नोड्स एक्टिवेशन फंक्शंस okay let me know once you are done then we can proceed तेजस हो गया यश अंकिता डन अंकिता नहीं है तेजस अच्छा ऑनलाइन ओके ओके फाइन नेक्स्ट इज वी विल रीड द फाइल Let's call this cars. Colon. अरे क्या कर रहा हूँ? हो गया? Now we will drop the column called name. So you can use cars dot drop columns equals name in place equals to, and then cars dot columns. So you can see here, now it is MPG, cylinders, displacement, horsepower, weight, acceleration, year, origin. Name column has been removed. So I'll just write the comment here, do the EDA tasks here, okay? Null check, blanks, imputation, cleaning, all these things will come. तो सब यहाँ पे कर लेना. How do you check for nulls?
Robin.
Hmm?
Is not
Hmm.
some of the.
So there are no null values. Okay, so similarly do the others also. Okay. Now we will standardize path हो रहा है? Installation हो गया? हो गया? ठीक है, in the meanwhile you can execute these things. ये सब चल जाएगा. Parallelly let the installation happen.
Can we, do we check for singularity in this
EDF का part है ना वो.
correlation?
All these things will be done EDA. Correlation between features, singularities, nulls, blanks, zeros, duplicates, imputation of missing values. Done? Sure. Now we'll standardize the data. Okay, this exercise is for you. Use the min-max scaler to standardize the data. Karo. What is the procedure for standardizing the data?
We put the min-max scalar, then fit the min-max scalar on data.
Uske pehle, what is the first thing you have to do?
Define the min-max.
You have to make a copy of your data set. Okay. Otherwise, you will lose your original data. In case if you have to refer to the original version. So first make a copy and then do the transformation.
But what?
Cannot find the. People have changed. You have changed. You are. Yeah, but we take it for you.
अच्छा है भाई दिवाली के वक्त करना चाहिए तो
डेटा नहीं Yeah. that's-
Upload yes, then maintain by 8.7. Because of the suggested final entity. Yes, another more relaxed, like sponsor can be guys. Stop with it. But it means to रिटेंशन रेट वाढत आहे ना दुसरे MIT प्रायव्हेट चालून वेस्ट प्रायव्हेट चालून त्यांचं कसं पब्लिक ठरलेलं असतं ते त्यांचं तर प्लॉट ठरलेलं आहे आणि फरक पडत नाही युनिव्हर्सिटी म्हणते हा त्याचं गॅप लागेल 1 वर्ष कोण गॅप करणार
हो गया प्रीप्रोसेसिंग हो गया
बिल्कुल डायरेक्टली फिट होती है
डायरेक्ट
डायरेक्टली फिट हमने अप्लाई किया ये आई लॉग नहीं किया ऑल रिजॉल्व कॉलम
हाँ तो वो डेटा फ्रेम में आएगा हमको ऐसा वेक्टर चाहिए एज अ टेंसर चाहिए सॉरी मैंने ऐसा एरे फॉर्मेट चाहिए
प्रेजेंटेशन स्टॉप हो गया
प्रेजेंटेशन
दिखने वाला है
मैंने तो शेयर किया हुआ है यहाँ पे एक सेकेंड I'll stop sharing and again do it अब दिख रहा है
हाँ दिख रहा है idea
ठीक है, तो I have two data sets, cars and cars min max. Original data. Okay, original data. ठीक है, original data and this is the min max data. Now when we are building the model, we have to use the min max format. But what should be the y?
Why is it MP?
Y value क्या होना चाहिए?
Continuous.
है continuous. All these things are fine, but what should be the value? क्योंकि ये भी convert हुआ है into min max format. जब predictions आएगा तो format में होगा, min max format में होगा, isn't it?
Yes.
So if you are retaining the min max format, predictions will be in min max format. You have to retransform it to get it into the actual format. Or you can take the min max format, उसपे change the y to its original format. Same thing. So here we will change it in the min max format. So we will write cars underscore min max dot mpg equals cars dot mpg. Okay, so now you can see the first one is the actual data. The second one is the min max format. But the y value is having the same value. Done? Tejas हो गया?
Yes.
पार्थ हो गया? अंकिता डन? Okay, the next step is split the data into training and testing. So I'm splitting my data into 75-25, 80-20 ratio, where training has 80% and so 313 records in training and 79 records in testing. Okay. So this is the first part, which is quite similar to the ML techniques. Now we'll come to the DL part, which is design the network. So in this part, we are going to create the number of input nodes, layers, and in each layer, how many nodes, activation function, output, all these things we are going to define. Okay. So we are going to create a function to create network. And so the first parameter is how many nodes you want. And what is the input shape. ठीक है, अभी देखो now this is my input data. This is my hidden layer and this is the output. Do you know the input layer?
Yes.
We know. ठीक है, तो वो कैसे मिलेगा?
Format,
इनपुट में क्या है?
variable, function.
What is my features, right? Do you know how many features you have? So we have to specify that length. ना मेरे पास 8 फीचर है, 4 फीचर है, 10 फीचर है, right? So this is the input shape. ठीक है, shape है ये, not the actual input. Okay, so you have to first specify what is my input shape. So ये कैसे मिलेगा? By the length. Okay, so if I use length of the columns, let's say 5 है, so this will return 5. So my input shape will be 5. ठीक है? So when this goes to the layer, that is a hidden layer, इसका input क्या है?
No.
Input क्या है इसका? That is input shape क्या है इसका? We do not know.
No.
ठीक है? So this will come from the left hand side to the right hand side. So when we are defining the input layer, we have to define the size. When we are defining the hidden layers, we don't specify the input shape. वो calculate होके automatically the shape and size is calculated. ठीक है? Output का linear regression है, तो output का size क्या है? There is only one. है कि नहीं? Y variable is only one, MPG. So इसका size we know, इसका size we know. So this is going to be length of features. This is going to be 1. Okay. Okay, we'll just design the basic network. और भी बहुत सारे हैं इसमें. We'll just define this and take a break. Okay, so in the compile model, we are first going to define what is my dense layer. Okay. So my model is going to be sequential already defined. Now I told you that the deep learning, what we are doing is a sequential model because it goes from left to right. So the outer function will be sequential. Within the sequential, you have the layers. Hello, Ankita, are you there?
Yes, sir.
Okay, are you able to understand these DL concepts?
Yes, sir. Yesterday I was not there, so
Ah,
this code I'm able to understand.
okay, okay, okay. So go through the video also if you have the access.
Yes, sir. I've seen, but yesterday's video was not uploaded.
Okay, okay, fine. But ensure that you understand these basic terms before you, implement the hands-on. Okay, otherwise you may have to do a lot of reading first.
Yeah, yes, sure.
Okay, let's start. ये आपको you will need the libraries installation हो Okay, so in the model building process, the first step is we define the sequential, and within the sequential, we have to define our list of layers. Okay. So this is going to be my first dense layer. So I'll write dense. How many nodes I want? What is going to be the activation function? Linear regression, what is the activation function? क्या बोला था? Linear regression का what is the activation function? कल क्या बोला था? You remember? It is called ReLU. And then input shape. So this is the first layer, which is the input layer. Now comes the hidden layer. And this is the output layer where I have only one shape, which is 1. I'll just compile this just to check if there are any errors or not. So this is a very simple model, simple network where I have one input layer, one hidden layer, and one output layer. Okay. Now set the learning rate.
These are the exact that compile word function.
Okay, so I'm going to pass the learning rate also. So this will again come as an input parameter. So I'll set the learning rate. And I can default it to some, I told you learning rate is a small number. So let me default it to some default number, which we can override during the model compile, during the compilation of the model. Compile the model. So model.compile. Now, because we have a linear regression, so the loss function, what is the loss function in linear regression? Y minus Y bar. Sorry, Y minus Y hat. क्या वो? Mean square error. Okay, 1 upon M into 1 M minus M Y minus Y bar whole square. That is mean square error. So MSE. So loss function is mean square error. Optimizer is going to be the optimizer that we have created at the top. And the evaluation matrix is going to be MAE, or I can use MSE. Either one is enough, or we can use any one of these two. Okay, so this will be the evaluation metric. So once the model is compiled, I have to return the model. Clear? Basic definition of a network कैसे करना समझ में आ गया? So we have a sequential layer, a sequential model. Inside a sequential model, we have the layers. The first layer is a dense layer. Sorry, all are dense layers. The first one is the input layer, then the hidden layers, and the output layer. Okay, so उसी sequence में we have also constructed the network. Fine. Okay.
These steps are would be common for having models.
Steps are common, but how many nodes you have to specify, how many layers you want to specify, that will change. इस पे एक layer है ना? That is only one hidden layer. This is the hidden layer. You can write here. This is the hidden layer. Hidden. You can write here hidden layer 1. So if you want a multi-layer perceptron, add one more dense layer, hidden layer 2.
How we are going to figure that it's a multi-layer? So culture discussed here. So we were having that multiple nodes in the hidden, right? That's why we will be figuring out the multi-layer and but यहाँ पे तो हम define कर रहे हैं ना कि like ये single layer है ये multi-layer तो वो implementation में कैसे पता करें कि multiple layers हैं
यहाँ पे ना यहाँ पे ये क्या है? This is single layer perceptron क्योंकि एक ही layer है. ये वाला जो हमने अभी किया है, this is what? This is input. This is hidden layer 1 and this is output. ये क्या है? Single layer perceptron.
इसका सिनेरियो कैसे होगा कि मल्टीप्लाई
ये मल्टीपल नहीं होगा ना.
Dense one नहीं डाला है।
This is what we have created. ये input है, ये dense layer 1 है, ये output है. Okay, now what will change? ये fix है, ये fix है. Okay, we can change the number of nodes and we can add one more layer here. तो यहाँ पे एक और definition आएगा dense. If you want to add one more layer, we'll put one more dense. So that will be input. This is the network 1, 2, 3. And then this is output. Clear? Okay.
जो हमने तुमने अभी बोला था dense नोड जो है रिपीट किया तो लेयर बढ़ जाएगा।
कहाँ पे?
जो हिडन लेयर 1 लिखा है सपोज तो कॉपी किया और फिर से पेस्ट किया और लेयर नंबर 2 ऐड हो जाएगा उसमें।
ये दिस इज इनपुट लेयर. मैं यहाँ पे भी लिख देता हूँ.
और नोड कैसे इसमें जनरेट हो गया?
ये इनपुट लेयर, ये आउटपुट लेयर. ठीक है. This is very difficult to remember, yes. Don't bother about remembering, but understand the concepts. That is more important. Done? Model compile हो गया? I mean function compile हो गया? Okay. Now let us. अच्छा, one more thing. See, there are multiple ways of building these kind of models. एक है when you are running the model building part, output screen पे दिखता है. Okay, so you can see the entire training errors, testing errors displayed on the screen. Okay, so do you want to get that or not? इसको enable करना है या suppress करना है? So you can do that. Okay. Now suppose let's say you are building a model which has 5 layers and it is going to take a long time. और आपका epoch is let's say 5,000. So you are going to get a lot of output on the window. Continuously scroll होगा वो. Okay, so do you want that kind of an output or no? Okay, so that you can either enable or disable. I'll show you both the techniques. Other technique, what you can implement is, let's say the model is getting built. Let's say you have 5,000 epochs. Now I want to say after every 100 records, you put a star or you put a dot. That shows the progress. 100 हो गया, एक dot. So dot, 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 till it reaches the last epoch. Okay? That is a more, I would say, a cleaner way of compiling the model or building the model. Okay? So first we will see how to put these dots as an output. And in the next session, we will see how to get the output in the window. Okay. You know what is a callback function? Computer science में क्या है?
callback function is where we give a response and resolve on.
कुछ सेंड करके उसको रिवर्ट करता है और वापस repossess में
It is used in JavaScript, right?
So submit, you can use it anywhere. क्या कंप्यूटर साइंस स्टूडेंट ये शायद फर्स्ट सेकेंड ईयर में पढ़ा होगा या फर्स्ट ईयर में.
Second year JavaScript.
रिटर्न फंक्शन की तरह काम करती है.
You can call a function as a parameter. Callback functions. ठीक है, so we will write a callback function here. So create a class to print dot to indicate a progress of model building. To indicate the progress of model building. So we'll call this function called print dot, which is derived from a callback function supported by Keras, which is called Keras dot callbacks dot Keras dot callbacks dot callback. Okay, so this is a class. Now here we are going to define a method. Okay, now these are terms which are inbuilt. ठीक है, ये जो method का नाम है, that is called on epoch end. So on epoch end will take the epoch number. Okay. It will take the epoch number as the parameter, and there we will check whether that number is the 100th. Okay, 100, 200, 300, 400, जो भी हमको चाहिए. So how frequently you want to display the dot? Okay, so we will do the input like this. So we can take here the epoch, self dot self, then epoch and lines. So this is the list of parameters that this function takes. हमने oops में किया था, याद है? What is self? The self-referencing pointer. So every function that you're defining within a class should always have the first as self, then the list of parameters. So here the parameters are epoch and lags. And now you can check if epoch percentage. Now, how frequently you want to display the dot? After every 10, after every 20, after every 50, when? Okay, so let's say I want to give after every 10. ठीक है, तो उसका मतलब क्या है? So if the iteration is in the 5th position, that is the 5th iteration, so 5% 10 क्या देगा? 5. Okay, but we want the output to be 0. So 10% 10, 0. 20% 10, 0. क्योंकि remainder is 0, right? But if I give 25% 10, 5. So we want to check the condition when the epoch percentage 10 is 0. That means it's a multiple of 10. Okay? So put the condition if epoch percentage 10 equals 0. So print a dot. So print a dot and after that leave a space. End का मतलब ये. So print a dot and then suffix that with a space. Clear है ये? Compile this class. Okay. Now let us train the model. Train dataset. Now, when we are training the data, I told you that the output will be on the screen, training data and test data. Okay, now instead of getting it on the screen, we are going to print dots. But the output of that function will be a error history. So instead of seeing it on the screen, you can get it as a variable name. So model is what we have got as an output here, isn't it? Compile model. So इस model को हमको train करना है. Okay. So here, let us first compile the model. With the initial parameters. Let's say nodes equals 10. Shape equals, what is going, how do you get the shape? Len of what? Which column?
Which is
कौन सा?
Cash min-max dot length. जो हमने डबल किया कॉपी किया था
हाँ, but length of what? Think and tell.
column
Train X. Okay. Because only train X contains the features, है कि नहीं? Shape क्या है? Input features. So it is going to be length of. समझ में आ रहा है? Train X dot shape. Sorry, columns. Or you can also write train X dot shape of 0. एक ही है. Sorry, not 0, 1. So there are 7 features. Or if I use length of train X dot columns, that will also give you the same number, which is 7. ठीक है? दोनों both are same. So nodes equals 10. क्यों? तेरा स्प्रिंट नहीं हो रहा माने?
जो हमने क्लास जो रेड क्लास किया है ना,
हाँ
उसमें जो प्रिंट डॉट केरस फोल्डर है,
हाँ
वो इशू आ रहा है।
क्या फैक्टर कंपेयर करें? उसका आउटपुट कुछ नहीं है।
मैं
आउटपुट कुछ नहीं है। फंक्शन को नहीं दिया।
The callbacks lowercase. नहीं वो uppercase. Okay, so now let us build the model. So let's call this model as M1. So M1 equals our function name is compile model. So compile model. Nodes equals nodes. Input shape equals okay. Okay. समरी में देखो क्या दिखा रहा है. Number of input features multiplied by nodes. सुबह जो हमने कैलकुलेशन किया था प्लस बायस. So how many features are there total? 201 parameters. Clear है ये? Okay. So model compile हो गया. So now we are ready to train this model. So M1 dot fit. मॉडल किस पे फिट करते हैं? मॉडल किस पे फिट करते हैं? ट्रेन पे करते हैं ना? ट्रेन वाई पे करते हैं. देन ट्रेन एक्स पे करते हैं. ट्रेन एक्स एंड वाई. Okay, no, train X is the input, train Y is the actual data. So build the data on the train, which is train X and train Y. How many epochs you want? So epochs equals. Now you can create one variable here called epochs. So epochs equals. So initially we'll start with a small number. So let's take 1000 to begin with. Okay, so epochs is going to be epoch. Now I told you that when you build the model, I don't want to see the output on the screen. उसको क्या बोलते हैं? Since you are in that same you must have also done this. जब कोई प्रोसेस चल रहा है, we want to suppress the output, है नहीं? नहीं तो वो स्क्रीन पे ऐसा continuously it keeps scrolling. So what do you call that? It's a very common thing to do in customer support net. It is called verbose. verbose, verbose. नहीं सुना? अरे? Verbose means whether you want to suppress the output or keep the output. ये बहुत very commonly used, especially when we are doing bug fixing, when we want to see the output, scroll करना है नहीं करना है. So we use this term, okay, verbose. So verbose is a parameter. If I want to suppress it, you give 0. Now, within the fit parameter, we can also do cross validation. Cross validation, पता है क्या है? Everyone knows what is a cross validation. अभी लगता है शुरू से करना पड़ेगा. Another 6 months. Validation नहीं, cross validation. Which data? Correct. So train data, when you are building a model, you are checking whether the prediction done on that same data is good or not good. ठीक है, उसको बोलते हैं cross validation. So we take the train data as it is, उसको split करते हैं. Okay. So we have a parameter called validation split. So in the output, if I turn on the verbose, you will see you have the train output and the validation output. दोनों दिखाएगा. So how much validation that you want to do? So if I put 0.2, so if my train data is 80%, उस 80% में 20% will become validation. That is cross validation. समझ में आ रहा है? That is why you should always remember what you have done. ये सब वहीं से आ रहा है, nothing new. Okay, and then the callback function. So calling a function as a parameter, that is called a callback function. So callbacks equals print dot. And this fit parameter is going to return errors. The fit function will return the train and validation error history. देखा, now you can see the dots getting printed. ये देखो, तो कितना dots आएगा? There will be 100 dots because 1000 divided by 10. So then you can see 100 dots. मॉडल कंपाइल हो रहा है. Now, if I give verbose equals 1, then see what happens. This is the output that you will get. इसको बोलते हैं verbose. तो ये जो स्क्रीन पे दिख रहा है, the same thing is seen as an output. तो E1 पे यही डेटा स्टोर हो रहा है. So we don't want to see this. ये continuously scroll होता रहता है. So we are suppressing that. ठीक है? So see here, epoch 77, 800, 850. So till 1000 it will execute. And then stops. So ये convenience है. If you want this output or not, I generally prefer verbose to be 0. And now if I see print E1, क्या लिखा है? Callbacks dot history. So that means it contains the history of the model. Train error, validation error. Train accuracy, validation accuracy. Okay. अब इस E1 में से we have to extract the history portion जो हमको स्क्रीन पे दिख रही है. ठीक है? So we will do that. समझ में आ रहा है कि नहीं? Everyone. So we'll create a function called error history. और इसका definition क्या होगा? To extract the train and validation error slash accuracy of the fit function of the model for every epoch. हर एक epoch का देगा ना? If you remember the output क्या था? Epoch 1, train validation. Epoch 2, train validation. So we'll get it in the same format. ठीक है? So we can write history equals errors is nothing but this E1. ठीक है? So errors dot history dot history. Okay, I'll just show you the output here. E1 dot history. ठीक है, अब इसको if I see it as a data frame, this is what I see. ठीक है, so you can write here pd dot data frame. So this is the error. This is the error history. Now can you, I'll just इसको थोड़ा maximize करता हूँ. Okay. Now just go through the output and tell me what is happening in this output. MSc का देखो. Very good. The errors are reducing, है ना? Gradient descent क्या करता है? It is trying to come to the global minimum. तो global minimum यहाँ पे assuming it is 0. तो कहाँ से शुरू हुआ देखो? 5. तो you are at the top of the hill. फिर धीरे 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 you come down, and then the errors will reduce. That is what I told, isn't it? When you come down step by step, you are reducing the errors. And now look at the last number, it is 1.4. So that means gradient descent is working properly. But is this the optimum value? That we do not know. Testing के बाद you have to optimize. Either give more layers or give more epochs. अभी मान लो अभी 20,000 epochs दिए. So now you will have 20,000 observations. And now you can see a very small decrease in the error. 1.4001, 1.4, 1.39, 0003. Very small reduction in the error. So too many epochs is also a problem. Too less epochs is also a problem. Okay? Now look at the right hand side. Validation. Validation means cross-validation results. Is that decreasing? Which fluctuations हो सकते हैं because of the way the data is. Okay, but overall performance is also similar. It should be similar. ठीक है? So this is how you read the history file, history output of the fit model. So history equals data frame dot this, and then I can also include the epoch as one of the column names. Okay, so now you can run this function. So get the error history of model 1. So I can write model 1 error history equals error history. What is the error parameter? E1. Because E1 is the object for the first model. So E1. Now print M1 error history. अभी देखो first epoch. So you can actually make it from 1 to 1000. So first epoch. What is the loss function? What is the MAE, MSE? Okay, you can take any one. So loss function 5, the last one is 3. So you can see there's a gradual reduction in the numbers. This is the first thing you should see. Is it reducing or not? So this is where the gradient descent function algorithm comes into play. Validation में क्या हो रहा है? 7.2, 7.3. ठीक है? If you want, you can plot the graphical representation to show this. Otherwise, this is only for your analysis. You don't have to show any specific pattern.
As 591.
क्या हुआ?
MSC 591 plus 1.
591. Yeah.
23.
फाइव 91 आने का तो स्कोप नहीं है. एक और no, that's okay. The data. X test X Y test Y. That is the problem. The next of shade. X is
We're taking same training shape.
X. Reading assistant. मैं इतना एरर आ सकता है the way we have sampled it, quite possible क्योंकि errors are reducible. एक बार resample करके देखो क्या आएगा. Just run that train test split again, get a difference here.
It is because of random.
Yeah, you can have an effect. Here you had how much? 579.
0.91.
That's a drastic drop. 591 seems 6. It is possible because the data probably was limited. But for unusual, it should not happen.
It was like a tumble down the mountain.
Jesus. Show me the numbers. 591 suddenly there is a two-digit number.
Single digits and 6 again.
591. See 591. Then suddenly there is a 10 and 6. Sorry, something is wrong with something.
Right. B19 and then some data and like 6 5.
तो ठीक है रीसैम्पलिंग के बाद it should get fine. हो गया? Okay, now let's do the prediction. Ankita, done? Okay, so now let's do the forecast, the predictions on the test data set. So let's call this as P1, prediction 1 equals model 1 dot predict on the test data. Okay, now because this is a tensor, we have to convert this into an array format so that we can store the result in a data frame. Okay, so we will use a function called flatten. Okay, so let's look at the first 5 observations.
Sir, can we pass the other parameters like what are the tire weight? Yeah.
Tire.
I'm checking the parameters. Like the cylinder displacement and horsepower for prediction. We don't have the car in the data set.
Car.
The car data set, right?
Hmm.
मेरे को ना एक नया कार प्रेडिक्ट करना है कि ये कार आने वाले मार्केट में इसका माइल पर गैलन क्या होता है, तो मैं सिलेंडर डिस्प्लेसमेंट और पास करके एलपीजी कर सकता हूँ।
That will be your test data. So create a array which will have those in that right sequence. तो टेस्ट में देखो what is the sequence of the columns, पहला कौन सा है दूसरा कौन सा है. So create your data in that same sequence, pass it into the test, it will do the prediction. Okay, so now we have done the prediction. Now we have to store actual data and predicted data in the data frame. So let's call this as data frame 1 equals pd dot data frame. Actual value कहां से आएगा? Actual miles per gallon. Which one? Test y. Test y. So this is going to be test y. Predicted P1 है. ये राउंड क्यों नहीं हुआ? Okay, so now see. Actual data 23, prediction 26.3 for that record. 23.5, 25.4, 15, 13.6, 19, 18.95. Now, how do you evaluate this model? Predictions हो गया. अभी इसको evaluate करना है. What is the evaluation parameter? Mean square error, right? So MSE 1 equals mean squared error. Actual data, so DF1 dot actual and predicted value DF1 dot predicted. Now you can print. You can just write a function called print results. You can say print error. Model name and MSC. And then you can write print model equals plus model print MSC equals slash n RMSC equals dot format MSC Here we can write print error model 1 and MSC 1. So model equals model 1, MSC is 6.9, RMSC is 2.6. So in the linear regression of machine learning, we have a function called plot best fit line. Okay, so you can take that function as it is. So is this a good model? Yellow actually it's not visible. Change it to black or something. So what should be our ideal MSC or RMSC? Very close to zero. Okay, but this is not always the case. It all depends on the data. So do not think that every data will have an error it's lying close to zero. Sometimes this can also be a good model. Now, the challenge is how do we improve the performance? Can I have a better model?
We can try by increasing the epoch.
Yes. Next is we have to increase the epochs. So try this as an exercise from 2000. Try to make it 4000 and see if there is a difference in the performance. But don't lose the original data, I mean the original values. Create a new model called E2 and do it. That's why I wrote functions, so that you don't have to rewrite the same thing again and again. So you can change the network, you can change the learning rate, you can change the number of layers, you can change the number of nodes, but you cannot change the input shape. Okay, so these are the list of hyperparameters that you have to tune in. So try doing 1 or 2 changes and see if you are getting an improved model or not. Okay, and that will be the last exercise.
We can show the function.
कौन सा ये? This one?
Best. Plot best fitting.
Okay, this is there in your code, your linear regression. Coding wise it is easy, isn't it? You're able to map what you studied yesterday. It is. समझ में आ रहा है? So to improve the model performance, we can change epochs, we can change network definition, we can say here. And we can do feature selection. What is your data? Spelling is not easy. Nikita, do this exercise, improve the model performance and see. And check if you're getting a better results. Okay, you can fine tune these parameters. पार्थ, ये हो गया इंस्टॉलेशन? अभी भी चल रहा है? ये कुछ ज्यादा ही टाइम ले रहा है? प्लॉट अलग विंडो पे लिखिएगा और एक टैब करके देखिएगा रहेगा। X plot takes value 0 to 1, but you value.
Correctly, I had changed the parameter, it is showing that. My spider doesn't update the. Same as that.
This value is, yeah, this value. So actually, before I had changed the parameter of best fit line here, df dot actual and df dot predicted. So it was showing this error there. And it did not change the state error. Quite a means. No, if you change this to now, the same error will come.
No, you cannot put df here because this is inside a function. Log x from 0 to 1 position. Simple. Acha, acha. I think they have changed. Okay. नहीं, ये नए वर्जन पे इन्होंने डेफिनेशन चेंज किया है रेड प्लॉट का लुक एट द डेफिनेशन ये जो रेड प्लॉट है पहले ये डेफिनेशन था now the new version they have changed the signature so you have to first give what is your data source. What is your data source? So data equals data frame name. फिर x क्या है y क्या है कोई एरर तो मेरा शायद एक क्वेश्चन पुराना है इसीलिए बोल रहा हूं तो जस्ट मेक दैट यहाँ पे देखो कोड देखो data equals data frame name x equals which column we want y equals which column we want यार पाठा क्या है यहीं पे देखो ना यार क्या है नहीं this is how you learn ये देखो यहाँ पे so here you have to write data equals whatever it is data frame ठीक है X
क्या हुआ? सब है। एक मिनट यहाँ पे इसको अनडू कैसे करते हैं? माइक्रो डिलीटेड सेल्स।
parameter is data frame. Data equals df. X equals actual. Y equals right? Yeah. Now this will come out. हुआ फिक्स हुआ Next week, we will do classification using deep learning. And we will do two types of classification, binary classification and multi-class classification.
हम सिंगल लेयर मल्टीपल लेयर था और उसमें आगे कैसे क्रिएट करेंगे ठीक है तो दूसरे सिनेरियो कैसे होगा
Scenario means
क्वेश्चन से सिनेरियोस तो प्रिडिक्शन करना होगा
हाँ
तो हाउ डू वी जज दिस क्वेश्चन में सिंगल लेयर पे करना है मल्टी लेयर पे करना
that is your choice based on the accuracy or based on the MSC. See, simple ये है कि more layer means more complications, more complicated network, ज़्यादा time लगेगा. Okay, but it does not guarantee good results. So you can try with add one more layer. अभी मान लो मुझे I want to add one more hidden layer. So how will your function definition change?
We'll add the hidden layer.
So now go here. And here I will put dense. Okay, now how many nodes I want? So I can put nodes -3, for example. Because I can have as many nodes I want. So increasing, decreasing, up to you. So nodes -3 means 10 है तो next will have 7. ठीक है तो यहाँ पे activation equals rel. So this is hidden layer 2. Okay, other things will be as it is. So now I have 2 layers with so many nodes.
Yes, because when like containing like daily use of like multiple layer of the scenario item.
There is nothing called multiple layer scenario. It is up to you to decide. अब इसका performance देखते हैं. So we already have seen M1. ठीक है. Now let's do this. Let's compile this function. Now let's ये ऐसे ही रहेगा. So let's call this as M2. Okay, so this is M2. Now I want to fit the function. ठीक है. So epoch I'll retain as it is. And here I'll put E2. This is going to be M2 dot fit. Model build हो गया ना? Compile हो गया. Okay.
Sir, if the machine should have been fast, this was faster.
See, this is all parallel processing. You know, ये सब parallelly built हो रहा है.
I had created a project in last few months. CPU versus GPU computational power. Which we try to prove that CPU parallel processing is better than CPU serial processing.
Okay.
So we had used it for encryption replication.
Nice. ठीक है, अभी ये हो गया. Now let us अभी हाँ इसका हिस्ट्री देख. तो ये randomly आएगा because of the layers कैसा है, the initial value of W कैसा है, so this can happen. So do we see any improvement? I don't know. We'll just check the results. All these things could be put in a function. ये बार-बार call नहीं करनी इसको. See the difference. ठीक है, तो adding new layers need not necessarily mean better models. You're only increasing the complications. So the performance depends not just on nodes, models, nodes and layers. Okay, quality of data. Okay, so this you can play around with.
तो कोरिलेशन में वो जो है मैंने निकाला है इसको हमने
तो वही मैं ना यहाँ पे इनिशियली मैंने क्या बोला था, डू द ईडीए। कहाँ गया वो, यहाँ पे डू द ईडीए हियर। तो हमने सिर्फ नल चेक किया है, वी हैव नॉट डन एनी अदर ईडीए। So that is why the EDA part is very crucial. Okay. Chalo then, so. Okay, Ankita, see you next week. Do the practice. If you have any questions, let me know.